Let's do this. So in the previous video, we talked about, we've written a simple code, test.cpp, which was for solution as couple ODEs, right? Let's take a look at it. To recap, we had f and g functions, Runge-Kutta, and then print vector, and then we had our main function. Solution vectors, initial conditions, and we used the function and we printed our results. And we had our function definitions also down here. So let's take a step back. I want to talk about very important principles in C++ for design and development of your projects. But these principles, applying these principles right now in this very simple example, because our code base is very small in this, it might sound a little bit trivial or dubious, but I want you to just grasp the principles and learn why we do things the way we should do things. Not specifically for this example. This is just a showcase. So we take a step back, and let's say we haven't written this program at all, and somebody came to us and said, "Hey, somebody claims that he has written a very beautiful Runge-Kutta fourth order solver for a couple system of ODEs. Can you take a look at it?" And then we plug in everything, and then we say ls, and oh, who doesn't like simplicity? There's only one .cpp file. This means I can jump right away and say test.cpp and compile it. Of course, it complains about a feature that is used in the code, which is part of the C++11 extension. Not a big deal. I can say C++11, and I have my executable. I can test it. I can get results out of it. Looks good. So this means if I know the logic, if I read this file and understand the logic of test.cpp, I basically know how it works, right? So let me change this test.cpp to main.cpp just to give it a better name. I go to the main.cpp and I say, wow, holy moly, I have a lot of function declarations right here. And then I have the main function, and check this out. I have a lot of nonsense function definitions down here, which they might not look that beautiful, right? So here's the general advice. Keep your main.cpp files as clean as possible, as concise as possible. Because imagine if I was about to extend this sort of program and then add another solver for a linear system of equations, for example, ax equal b, where a is like a n by n matrix of coefficients, x is your vector of unknowns, and b is the vector of known values, then I needed to add a shit ton of like other function declarations, and then at the bottom I had to add all those functions and stuff like that. And then even you couldn't see the main functions right away when you open this file. So somebody might say, oh, I got you. This is not a big deal. I can say Runge-Kutta.cpp. I can create another file, Runge-Kutta.h. And currently, they have nothing inside. Like I can open my main.cpp and I can open my Runge-Kutta.h. Then I can literally go here and take whatever function declaration I have. I cut it and I paste it right here. Since this is a header file, don't worry about this. This is just a convention to safeguard your header files, to avoid basically including header files multiple times, the same header file. So we say if not defined, this is the convention. If not defined, and then I say Runge-Kutta h, then define Runge-Kutta h. And I can also go down here and I say basically endif. So don't worry about that. This is just a way that you safeguard your header files. And then I can open up my .cpp file, and then I say, okay, let's open up main.cpp as well. And then I go down here. Whatever I have here as function definitions, I can take everything and literally cut them and then paste them right here and save them. Now if you go to main.cpp, look at it. Isn't that beautiful? Oh, I closed it by mistake. Isn't that beautiful? Now I have only my main function right here and nothing else. And let's take a look at it. As I have like lines of comments, it seems like the code is used for solution of couple ODEs, and then I have my solution vectors, bunch of comments, initial conditions, and oh, I use this magical function Runge-Kutta. I use also this magical function print vector, which seems like it prints any vector. So we achieved something here, right? Now we have a very clean and nice main.cpp file. But what was the cost we paid? The cost we paid is we added like another .cpp file and a header file. But let's not talk about this issue right now. How do I compile this? Let me remove this a.out. How do I compile this now? If I say g++ main.cpp and then I say standard is going to be C++11, the compiler says use of undeclared identifier Runge-Kutta couple. Where did this happen? In main.cpp, so of course say line number 24, which states right here. So I say line number 24 and the main.cpp. Oh, he's right. I'm using Runge-Kutta couple, but I don't know what that function is. So I go up here, then I say include. Of course, I need to respect this Runge-Kutta.h. Oh, not a problem solved. Oh, hell no. We have another issue, but this time this error seems a little bit freaky, a little bit cryptic. Now this time is a linker error. It says symbols not found for architecture ARM64. Then Clang comes and says error linker command failed with exit code 1. So if you work with Unix-like systems, you know that any non-zero exit code means a certain error. So things are not working as the way they should. So let's take a look at this directory. I have main.cpp and Runge-Kutta.cpp, but I tried to only compile main.cpp up here. So maybe that's the source of issue. So I say main.cpp and then Runge-Kutta.cpp, and then I add the standard to be C++11 again. Oh my lord, now I have a lot of errors. Use of undeclared identifier std. Where did it happen? In Runge-Kutta.cpp size and line number 10. So I say wim, line number 10, Runge-Kutta.cpp. And again, the compiler is right. We are using std vector, and this unit has literally no idea what std vector is. So I need to come up here and include, if I can spell it right, include vector, of course. And then, you know what? Down here, I'm using also std cout, so maybe I need to also include IOStream. So include IOStream. Okay, before going out of this file, I saved it, but here's another advice. Usually try to avoid adding header files in your .cpp files. So these statements need to be somewhere else. So I can save this, I can go to the header file, then I can come back here, put some spaces, and put this thing here. Now it looks nicer, right? So I have a header file which contains some function declarations, and it also includes some necessary, which like these things are necessary because my library is using these, right? So but one thing I forgot to do is come back to the .cpp file and then add the main include, which I have to include my own library, my own header file, right? .h. So now I need to save this, and I say G++ and I compile it. Oh, works beautifully. Compiler gave up. There's no more errors anymore, and he says that here you go, you get your executable. Let's run it. It works as intended. But what did we achieve here? What we achieved here is that now we have a very clean and nice looking main.cpp file. But wait a second. This means if I go to my main.cpp file, and one day if I wanted to add, for example, add this nice nice feature, if I can spell things right. And then I have to come back and compile main.cpp and on top of that Runge-Kutta.cpp. But I only changed main.cpp. Isn't that stupid that I need to compile both of them? Yeah, It is actually stupid. And right now, it might seem trivial, as I said before, also, because our code base is not large. Like compilation of this takes like fractions of seconds, milliseconds, or something like that. So it doesn't matter like for this specific example, but generally it does matter. When your code base is very large, it might even take you hours and hours to compile a piece of code. So here's the idea. We can use something neat as libraries in C++. I want to start with static libraries, maybe for the simplicity, or I don't know. I want to start with static libraries. So let me remove this thing and let me clear the screen. I can compile this Runge-Kutta.cpp as a separate block in a special way. How do I do that? I say Runge-Kutta.cpp, and the special way is I come here and I add a flag -c. Let's take a look at it. It says, again, the standard. Of course, I always forget it. And then I get another file as the output. It's an object file. Let's take a look at it. Oh, doesn't seem like human readable. Go back. I said I want to make a static library out of this. How do I do that? I do that with the help of a command or a tool called AR. We can take a look at man AR, and then here it says create and maintain library archives. Sounds interesting. So I say AR RVS and then Runge-Kutta.o. This is the object file, but I need to name my library, like, right? I say lib Runge-Kutta.a. Things to notice is that lib, and the extension .a, these are necessary to be there. So this is a convention for Unix-like systems that this is the convention that they name the static libraries. So if I hit return key, now if I take a look at it, I have my beautiful library there. It's a static library. I can also get rid of my Runge-Kutta object file. There's no problem with that. But how do I get my final executable? Okay, no problem. I say I have a library with capital L. The address of this library is right here in this current directory. What is the name of it? I'm going to tell you. Minus small letter L, and then you should not write lib Runge-Kutta, but instead Runge-Kutta, without any extension as well. And then don't forget to put the standard 11. I do this, and then I get my a.out, and it works, right? But what did we achieve here? What we achieved here is that if I now go to main.cpp and make any feature right here, like another feature, and if I compile my program, I don't need to compile Runge-Kutta anymore. This is just a standalone static library, and I just compile my main.cpp, right? Isn't that beautiful? We sort of separated the compilation step of Runge-Kutta, which was a little bit dubious or unnecessary to compile it each time. But wait a second. Now what if I come and go to Runge-Kutta.cpp and I want to add a feature right here? For example, I want to say std cout, I don't know, like say hello dum-dum. I want to do that. And I want to do an end line right here. If I do that and I compile my project, if I run the executable and run my program, I see that there is no hello dum-dum right here. But I compiled my main.cpp. Oh, this means that if I compile my library as a static library, and if I later come and make a change into that library, then I don't get my change here. So this means I need to do the steps again. So I need to say G++, and let me find, where did I have this? Maybe I will type it. No big deal. So I say G++ and then -c, and then I say Runge-Kutta.cpp here I have my object file with minus std C++11, and then I say arrvs, and then my library should be lib Runge-Kutta.a, and then the object file is Runge-Kutta.o. And did it work? Let me remove this and do the AR again. Oh yeah. So now I have my library right here, and if I say G++ with for the project itself, so main.cpp, and I link my Runge-Kutta library right here, now I get my executable, and ta-da, now it works. Hello dum-dum. So this means that so we solved a portion of the problem. Now if we changed anything in main.cpp, we don't need to compile Runge-Kutta.cpp again. We just say g++ main.cpp, and then we'll link the library. But if along the way, I want to make a change, if I wanted to add a feature to Runge-Kutta.cpp, it means that I need to compile everything again. This also sounds a little bit stupid, right? But here comes the idea of dynamic libraries. But before going into dynamic libraries, let me talk about this. Take a look at this. This executable a.out literally has all the information about Runge-Kutta.cpp. All the functionality of this Runge-Kutta.cpp is embedded inside this executable. What does it mean? It means that if I take this executable, put it in another computer, and then try to run it, it doesn't need to know about Runge-Kutta.a, because all the information is embedded, is hard-coded into this executable file. Isn't that nice? So this means that my application is very portable, right? Without knowing or without having any knowledge of these libraries, the details, I can run my executable without any issues. So portability, check mark, it's very nice. But now let's go back and talk about, let's remove this a.out, let's remove the static library, and let's remove the object file as well. Now we end up again with the same files as we had in the beginning. So we want to know how the dynamic library works. So we say G++. Again, I want to compile the same idea. I want to compile this Runge-Kutta.cpp, but in a special way. This I want to use a position independent code, and I want to also make a .o or an object file. Of course, I always forget to put this C++11 standard. And I get another object file, just as before, and I can convert this with shared and -o. I can call it as lib Runge-Kutta.so and then Runge-Kutta.o. Things to notice: lib again is necessary. This is the convention in Unix-like systems, and this time is not .a, it's .so. It stands for shared object. This is the convention for Unix-like systems to work with dynamic libraries. If I hit my return key, I see I have a very beautiful .so library, which I can link it to my main.cpp. Let's do that. So I say main.cpp. I have a library which is current in the present. It is present in the current directory, and then the name of it is again Runge-Kutta, and then I have the standard C++11 for this project. I hit the return key and I get my a.out right here. So I can run it and see if it works. Yeah, it works. But what did I achieve here with this dynamic library? Let's go and say, oh, who put this hello dum-dum here? This is a very dumb idea. Let's go to Runge-Kutta.cpp, and let's go in the end and remove this line of code, come back. And what I want to do this time is not to compile main.cpp, but I just want to compile like G++, and I just want to compile the -fpic, this one. I just want to compile this one with a C++11 standard, of course. And I get my, I need to remove this .so. So I got my new or updated object file, and I can say G++ again, and then use shared, or G++ with -shared, And yeah, I generate again another .so file, but I haven't compiled main.cpp, right? And this is the old executable. If I run it, wow, there's no hello dum dum anymore. Isn't that like very nice? So I changed something in Runge-Kutta.cpp, but I had to only compile my shared object, my dynamic library. It's a very nice feature. Now I sort of have very great flexibility. I can literally separate the compilation steps. If I change anything in main.cpp, I only compile main.cpp. And if I change anything in my Runge-Kutta.cpp, I need to only compile my Runge-Kutta.cpp, the dynamic library. But you might think that, okay, so why do we have static libraries at all? This seems like we have a lot of flexibility and a lot of nice features right here. But things to notice, everything comes at a cost. If I have my .so, my dynamic library, this executable right here, it has literally zero information about the functionality of this Runge-Kutta.cpp. So this means if I take this executable and put it in another system, in another computer, and try to run it, it will complain that, hey, I need to have access to a library, a shared library called librungekutta.so, but I seem to not find it on your system. Portability issue. Okay, so this means that along with my executable, I need to compile my shared object on the destination sort of system or computer. Another issue is that when I run this executable, um, only at the moment that I'm using this Runge-Kutta function, then it goes and asks, "Hey, I need this library actually." The operating system looks for this library at specific places, and it says, "Hey, I found it. This is the lib," and then you can use it, and you have your results. So there's a little bit of overhead, right? So there's a little bit of process of asking where this shared object is, and now I want to use it in a specific manner. So that's usually the case. Usually, the static libraries have a better performance compared to dynamic libraries. So this is not the whole story. So the static libraries have their own advantages, and dynamic libraries also comes with a lot of flexibility, and they have also their own advantages. As I said in the beginning, everything comes at a cost. So I think we've talked enough about static and dynamic libraries. But let's take a look at this. Let's clear the screen and let's take a look at this. I can remove this object file, right? I can say, let's take a look at this. I started with main.cpp, but right now I have a shit ton of unnecessary stuff which are distracting when I take a look at this project. So that is why in Unix-like systems, usually we have a lib directory, we have an include directory, and also we have a bin directory. What does it mean? It means that we take everything which is executable, we put it in the bin directory. We take everything which is like header files, CPP files, or things of that nature, we put it in an include directory, and we move our did I make a mistake? No. We take our library also and we put it in the lib directory. So now when I take a look at this directory, I see, oh, all my libraries, whether they are static library or whether they are shared libraries, they're included in here. All my header files or extra.cpp files are in include directory, and everything which is executable in this binary folder or directory. And now, of course, I have my main.cpp file right here. Now, when I want to take a look at, when I want to investigate this, I just go directly to the main.cpp and I see how it works. If I want extra information, I go to include and then I see, oh, from Runge-Kutta.cpp, of course, I have information about this as well. So let's go back. Let's go back and take a look at this. If I try to I have this, oh, I didn't go back. If I go to my bin directory and I say I want to run this program one more time, wow, what happened right here? It says the dynamic linker says I cannot find this librunge-kutta.so. Something fishy might have happened. We haven't done anything but just moving files around into separate directories, right? What is this about? If you are on a Linux system, then this means that there is, okay, at runtime, the dynamic linker must know where your dynamic library resides. So there's a very nice environment variable in Linux. In Linux systems, usually you can say export. Oh, so my library is right here. I can say like pwd to get the address. Then I can come back here and I can say, hey, export this LD library path into this thing, and then $, and then I say LD library path. Then I hit the return key. Now, if I say echo my LD library path, I can see that, hey, this thing is added there. Now, I should basically have information about this library, right? I go to my bin directory, and then I say a.out. Oh, holy crap, doesn't work. Why it doesn't work? That's because I'm on a Mac system. In Mac, things are treated a little bit differently than Linux. It is still a Unix-like system, but here we have our own environment variable for dynamic linker stuff. So what you need to do is to export another environment variable. It's called ld, just like this one. And then the same thing, library, and then path. Then you say equals to the same path that we entered before, and then $, and then .ld, and then library, and then path. And I hit the return key, and now I echo the same environment variable. Say ld this path, and then I see, hey, I have this address now available to the terminal. Now, if I try to run this a.out, voila, it works. Okay, this was the last trick that I wanted to talk about. But now sort of you have an idea, another sort of issue, not an issue, but another thing to bear in mind when you're working with dynamic libraries is that your sort of environment needs to know about at runtime of your application, needs to know where your .so or your dynamic library resides. And the way that I did it with the export is a temporary way. So if I close my terminal and I open another terminal, I can do this right now. Actually, to showcase this, if I say linking, that's the thing I have, and then I go here, say a.out, you see the same error again happens. Why? Because all the information only resides into the terminal that I have right now. If you want to have not non-temporary effects, then usually you need to do that into your bash. Either bash RC if you're working with Linux, or bash profile if you're working with a Mac operating system. So I hope you learned something about static and dynamic libraries, and we sort of now changed that very simple. We applied some very neat and important principles in C++ as static and dynamic libraries. And we applied it to our very simple example of solution of couple ODE systems. I hope you learned something from this video. And that's it for today.